Ever wondered how to design software systems with clarity, modularity, flexibility, and robustness in mind? Well, there's a handy set of principles just for that, known as GRASP. GRASP, which stands for General Responsibility Assignment Software Patterns, is a collection of 9 fundamental design patterns used in object-oriented analysis and design, or OOAD for short. These principles guide the assignment of responsibilities to objects in your software design, ensuring your systems are not only well-structured but also easy to understand and maintain. The 9 GRASP patterns are Information Expert, Creator, Controller, Low Coupling, High Cohesion, Polymorphism, Pure Fabrication, and Indirection. Each of these patterns addresses common design problems and promotes good object-oriented practices. But what do these patterns mean, and how can they be applied to your software design process? Hold on tight as we dive into the world of GRASP patterns. Ever thought about who should be responsible for a particular piece of information in your code? That's where our first pattern, the Information Expert, comes in. Now, the Information Expert pattern is all about assigning responsibility to the object that has the information necessary to fulfill it. It's a way of centralizing knowledge and behavior in the same object, promoting encapsulation and reducing coupling. Let's say you're designing a library system. Which class do you think should provide a book's title, author, and publication year? That's right, the book class. Why? Because it owns that information. It's the Information Expert when it comes to book details. Then we have the Creator pattern. This is about assigning the responsibility for creating an instance of a class to the class that contains it, uses it closely, or has the information needed to create it. Let's consider a simple e-commerce scenario. Who initiates an order? A customer, right? So it makes sense for our customer class to be responsible for creating order objects. By doing this, we're aligning the creation of objects with the real-world processes they represent, making the system more intuitive and easier to understand. So we have the Information Expert holding the information and the Creator bringing objects to life. But why are these patterns important? Well, they promote good object-oriented practices. They help us design software systems that are clear, modular, flexible, and robust. They guide us in assigning responsibilities to objects in a way that makes sense and aligns with the problem we're trying to solve. Remember, the goal of using design patterns like Information Expert and Creator is not to make your code look fancy. It's to make it more maintainable, understandable, and flexible. It's about writing code that not only works but also makes sense to others who might work on it in the future. In the end, using these patterns effectively can save you a lot of time and headaches down the line. They can make the difference between a project that's a joy to work on and one that's a constant source of frustration. So, the Information Expert holds the information, and the Creator brings objects to life. Simple, right? Now let's think about how we can manage system events and reduce dependencies between objects. Diving right in, we come to the Controller pattern. This principle is all about assigning the responsibility for handling system events to a single controller class or a closely related set of classes. It's like having a conductor in an orchestra, making sure all the instruments come together to create a harmonious symphony rather than a cacophony of sounds. Imagine an online shopping system. To keep things streamlined and manageable, we might have an order controller. This maestro of sorts would handle all requests related to placing orders, adding items to a cart, and processing payments. By centralizing control logic in this way, we're effectively managing system complexity and ensuring the entire process runs smoothly. Moving on, let's explore the concept of low coupling. The aim here is to reduce dependencies between objects. Think of it as the ultimate exercise in maintaining professional boundaries. Each object or class should ideally stick to its own business and not meddle too much in the affairs of others. For instance, we can use interfaces or dependency injection to decouple object relationships. This approach allows for easier modification or replacement of components. It's like having a modular kitchen where you can swap out units without having to redo the entire space. It's a more flexible, maintainable design because changes in one part of the system have minimal impact on others. In essence, the controller and low coupling patterns are about keeping things orderly and adaptable. The controller pattern ensures that there's a single point of control for system events, reducing complexity. On the other hand, the low coupling pattern safeguards against excessive interdependence between objects, promoting flexibility and maintainability. So, By mastering the art of controlling system events with a controller and maintaining professional boundaries between objects with low coupling, we're essentially setting the stage for a well-organized, flexible, and robust software system. So with a controller and low coupling, we keep our system organized and flexible. Moving on, we now focus on how we can keep our classes clean and how we can handle variations in behavior. Picture a bustling city. Every building has a purpose, and every citizen has their duties. This is the concept of high cohesion. Each class in our software city should have a singular focus, performing closely related tasks. This makes our code more maintainable and well-organized. Consider a class customer. It should have methods related to customer operations, such as registering, updating information, or placing orders. But you wouldn't expect this class to handle payment processing. That's a different task, better suited for another class. This is high cohesion, assigning distinct responsibilities to ensure each class remains focused. Now let's shift our attention to a theater. You see different actors playing various roles, yet they all follow the script. This is polymorphism. It allows us to handle variations in behavior. Instead of having complex conditional statements, we use polymorphic methods. These methods allow different classes to implement different behaviors. Here's an example. In an e-commerce system, we might have different payment methods. Each one has its own class, and each class has its own pay method. But the system doesn't need to know which specific payment method is being used. It just calls the pay method on the payment object, and polymorphism takes care of the rest. This approach makes our code more flexible and easier to extend. High cohesion and polymorphism are like the yin and yang of object-oriented design. High cohesion keeps our classes clean and focused, ensuring we don't mix responsibilities. It makes our code easier to read and maintain. On the other hand, polymorphism helps us handle variations in behavior. It keeps our code flexible and adaptable, ready to accommodate new classes or methods as our system evolves. So, let's keep our software city well organized and our theater versatile. High cohesion keeps our classes clean and focused, and polymorphism lets us handle variations with ease. Finally, let's tackle the last two patterns: pure fabrication and indirection. These may sound a bit abstract, but they're essentially about creating clear boundaries and reducing dependencies in your system. Pure fabrication is a design pattern that allows us to create a class that doesn't necessarily represent a concept in the problem domain, but is designed to encapsulate logic or behavior. This approach promotes both low coupling and high cohesion. Let's imagine this. We're developing a system and we need to handle database connections. Instead of spreading this responsibility across different classes, we can create a utility class. This class, while not representing a real-world concept, is entirely devoted to managing database connections. It's like having a dedicated specialist on your team who handles all the nitty-gritty details of database management, allowing the rest of your classes to focus on their specific responsibilities. Next, we have indirection. This pattern introduces an intermediary object to reduce coupling between other objects. In essence, it's like having a mediator that facilitates interaction between two parties. To illustrate this, imagine you have a class A that needs to communicate with class B. Instead of having them interact directly, which could lead to high coupling, we introduce an intermediary object C. Now, A communicates with C, and C communicates with B. This way, if B needs to change in the future, A remains unaffected and only C needs to adapt. It's a bit like international diplomacy. You don't always talk directly to the other party. Instead, you go through an ambassador or a mediator. In software design, using pure fabrication and indirection can significantly improve the flexibility and maintainability of your system. By encapsulating specific logic in a fabricated class and using indirection to reduce dependencies, we can ensure our system can adapt to changes with minimal disruption. And that's the beauty of these patterns. They may not always be the first tools you reach for, but they can be incredibly powerful when used correctly. With pure fabrication and indirection, we can encapsulate logic and reduce dependencies, keeping our system flexible and maintainable. And there we have it. The 9 GRASP patterns. A quick recap. We've got the information expert, keeping knowledge and behavior in one place, the creator, assigning creation duties to the most fitting class, and the controller, acting as the central hub for system events. Then we have low coupling and high cohesion, two principles that push us towards more maintainable, flexible designs. We also discussed polymorphism, which lets us handle variations in behavior more elegantly. Next, we touched on pure fabrication, creating classes that don't necessarily mirror real-world concepts, but help us maintain our design principles. And finally, indirection, introducing intermediary objects to reduce dependencies and increase flexibility. These principles may seem abstract at first, but they become second nature with practice. They're not rules, but tools to help you design better software systems. Use them wisely, and you'll see the difference they can make. Until next time, happy coding!